take a look at the first chapter, Technology Underpinnings. The objectives for this chapter describe infrastructure concepts and network architectures, identify operational technology types, outline operating system fundamentals, look at scripting languages, data exchange formats, and regex, which is a very powerful tool once you learn it. So, infrastructure concepts. Virtualization, it's essentially running a computer on another computer. You have hardware and software types of virtualizations. Hardware is the one you're going to be most familiar with in a bare bones area, but if you've ever used something like VirtualBox, a virtual machine like VMware, something along those lines, that's a software type VM. Used a lot in cloud computing. Hypervisor, type 1, those are the ones that are running on the hardware without an OS, and type 2 is the OS type. The VDI runs a desktop inside of a server, and you can access that from anywhere. So you can see here the difference. Type 1 hypervisors do not require as much resources because of the lack of needing to run a host OS. The virtualization itself has advantages because it keeps everything downloaded, isolated, and separated. If you need to make a change to your system, you can make a snapshot before you do so, which is essentially kind of a backup. You can check security configurations, you can make simulated network environments, you can clone virtual machines in much the same way. It allows for segregation, isolation, and malware testing. Of course, not everything has the right security controls. Not everything is ever going to be perfect. Things can always get out and break through. Some security tools don't adapt well to VMs. Some can, and some others will require protection from both themselves or their peer machine. Some VMs will also require outside network protection as well as the physical computer itself. And they may try to break out. That's something that is called VM sprawl. So here you see a virtual machine manager in SolarWinds taking care and looking at multiple of them. Let's see here they're using VMware and Microsoft Hyper-V, and you can look and see what machines are up and running and what their current statuses are. Another way is containerization. If you've heard of Docker, that is a way to run things within a container. It only holds the components needed for a specific thing to run. Another thing on Linux is something called a Flatpak, which is something I use pretty regularly because I'm using Linux for my own personal system. Networking, remotely, cloud, basically cloud, remember, nothing more than someone else's computer. Allows network access to configurable computer resources. Public cloud, open to everybody. Community cloud, only open to certain people. Private cloud, only created for a private specific network. And a hybrid cloud, combination of both public and private clouds. Probably see that a lot more than you will much of anything else. Example here is cloud computing. You've got users here on the network. They reach out to the internet. They find their cloud vendor, get whatever information they're storing, and bring it back and use it on their side. On premises, anything that's located within the campus or inside of the organization. Three-tier network architecture, that's your clients, your servers, talking to everything. So the client requests out to a web server then goes back to an application server then goes to the database server. The separation of duties is actually what helps with security and allows for larger networks to get broken down using virtual networks or VLANs through networking schemes. Those are jump server and air gaps. A jump server, for example, here is a DMZ that says, hey, on my web server and all of those, I want those stored here. And then those can talk then internally through the firewall to the database and application servers. Software-defined network is a firewall or router that says, hey, this is where everything works. Allows the network to shape, construct, and create everything from a central console. Operational technology. You can control processes for others' devices, processes connected to the infrastructure. SCADA, it's one of the larger ones you'll find if you work at all with utilities like electrical, water, gas. A lot of those are run by SCADA systems. Specialized ones, cars, medical systems, IoT, your thermostats, your coffee, anything that's quote unquote smart is an IoT device. This is just a small list of them, but they could be considered an ICS. Critical infrastructures do have risks, and these are protections then through your OT and your IT networks being separate. They have separate recording structure, and security focus on the OT side is your fundamentals, foundations, your system processes, configuration files, and hardware architectures. And you can also do system hardening within your operating system. The processes, they control your memory allocations, operating system drivers, other processes. These are running through kernel mode, which has full and unrestricted access to your entire computer and all resources. Files are set up in a file structure. For Windows, that's your C drive, D drive, etc. For Linux and Macs, it's the /tree structure. And on one of those files inside of there is your config file, which tells you where everything is. The database for Microsoft is the registry. Your architecture is working and maintained by your UEFI, or sometimes still called BIOS, and they can be targets for threat actors. It is usually pretty tough to work with those. They are almost always there. Firmware updates can cause errors, and sometimes people aren't comfortable doing the patches on them. So UEFI does have better security and increases your security there. It involves validating everything used during the boot process and making sure nothing's been modified. So you can see here the security modes. Legacy, older systems, has no security features. Native mode has basic standards in there, no validation or protection for the boot process. Secure boot, everything gets verified. Trusted boot has to use Microsoft OSs, and then measured boot will log to the OS and send it out to an external server. The two you're probably going to be seeing the most are either trusted boot or secure boot, depending on the type of system and operating system you're running. So the best thing to do is disable your ports and protocols, set an allow list for anything that can run, and as well as no unneeded services. Say you had a kiosk computer out in your lobby, you'd want to make sure that things like your USB ports are disabled, and if anybody plugs something in, it won't do anything to your computer. Programming languages, either scripting or coding. The difference there is whether it reads it in an interpretive mode or will compile it. They will talk to each other, talk to the hardware, and go back and forth. And then you have regular expressions or regex that will help match, locate, and manage text. The scripting language that now exists is something called VBA, used a lot in Microsoft Office for macros. Macros generally get disabled by default because they can be a major security hazard. However, you can turn them on if you know and trust the macros. Shell scripts on Linux or Mac or Unix, which is Mac or Unix based or BSD based, will allow you to run scripts from there. That's also bash files or PowerShell scripting files. Python is a good scripting language to learn. JavaScript, if you're doing anything for web pages, that is technically a scripting language as well. Python is used quite popular for many, many things. Data exchange formats, you have XML. It's been superseded today for JSON and executes faster than XML, and XML is not used much anymore these days. You see here the difference between the two for format, syntax, data types, file sizes, and securities. Regex, like I said, it is a string of text describing a search pattern. So this is the most basic of regex, which is the star wildcard. So if you do star, it will basically find anything with txt as a file extension. Many software programming and languages support regex. In summary, you can now describe your network concepts and infrastructure concepts for network architectures, different types of operational technologies, operating system fundamentals, scripting languages, data exchange formats, and regular expressions. Thanks for listening. Have a good rest of your week.